to problem 3, says the figure above shows the graph of the piecewise linear function f, and it says for negative 4 less than or equal to x less than or equal to 12, the function g is defined by g of x equals the integral from 2 to x of f of t dt. Now, keep in mind that g is defined as the area under the curve f of x from 2 to some point. So it's going to be helpful if I think of these as triangles and I'm going to find the area. So I know that this area here of this triangle has a base of 2 and a height of 4, so its area is 4. And in fact, all of these right triangles are all going to have an area of 4. The only thing I have to be careful of is that these values are actually going to subtract from the integral here. And these values here are actually going to subtract because I'm moving backwards on the domain. So I could think of these as negative amounts as well. And similarly, I could think of this triangle as a positive amount because I'm subtracting a negative. So the question is, does g have a relative minimum, a relative maximum, or neither at x equals 10? Justify your answer. So I'm looking to see g has a minimum if g prime is less than 0 on this interval from 8 to 10, and g prime is greater than 0 on this interval from 10 to 12. Well, let's see, g prime is really f. And what I notice is that g prime is less than 0, but g prime on this interval is also less than 0. So the question is, do I have a relative minimum, relative maximum, or neither? I actually have neither, because g prime is less than 0 on the domain 8 to 10 and the domain from 10 to 12. So I would need some type of transition from negative to positive or from positive to negative in order to have extrema here. Because I don't, because g prime is strictly less than 0 on both of these domains, then I end up with a neither solution. On part B, though, we're talking about points of inflection, so we're looking at concavity. And keep in mind that if g prime is f, then g double prime is really going to be f prime, or the slope of f. So what I'm looking at here is I really want to look at the slope of f at the point in particular, at the point x equals 4. So notice that g double prime is greater than 0 on the domain from 2 to 4, because my function is increasing on this domain. And g double prime is greater than, is less than 0 on the domain from 4 to 6, because my graph is decreasing. So what we've got here is we have a point of inflection at x equals 4 because, so g has a point of inflection at x equals 4 because g double prime is greater than 0 on the domain 2, 4, and g double prime is less than 0 on the domain 4, 6. So again, in order to know what g is behaving, I need to look at the behavior of f. In particular, I need to look at the first derivative of f, or the slope of f. Moving on to part C, it says find the absolute minimum value and the absolute maximum value of g on negative 4 less than x less than 12. I know that extrema occur on critical points and boundary points. Now, I know that I'm going to have a critical point wherever the derivative is undefined, which is going to be at all of these corner points, or where g prime equals 0, in other words, where f equals 0, which happens here and here. And then, of course, I've also got my boundary points, which I'm going to have to consider as well. And remember that I thought of these areas as triangles, all of which have a value of 4 or negative 4. And because we're going from 2 to the x value, we're actually going backwards on this domain. So this is a negative 4, this is a negative 4, and this ends up being a positive 4. So let's start with the simple one. G of 2 is 0, because the integral from 2 to 2 is going to be 0. So g of 2 is really equal to the integral from 2 to 2 of f of t dt, which is 0. G of 4 is going to be the integral from 2 to 4 of f of t dt, which is 4. G of 6 is going to be the integral from 2 to 6 of f of t dt, which is going to be the 4 and the 4 here, which is 8. G of 8 is going to be the integral from 2 to 8 of f of t dt, but for us that's going to end up being negative 4. G of 10 is going to be 0 again, and G of 12 is going to be negative 4. That's 0. So now I need to take a look at what's happening on this domain as we go backwards. So if I'm doing G of 0, that's going to be the integral from 2 to 0 of f of t dt, which for us is negative 4. G of negative 2 ends up being negative 8, and G of negative 4 ends up being 4. So I notice here that at G of 2, that is the lowest of any of these values that we've got. So we know that we have an absolute minimum at the point negative 2, negative 8. And we have an absolute maximum. We have our largest value here at G of 6. So this is going to be at the point 6, 8. And I know this because my extrema have to occur either at a critical point or a boundary point. I have to get values for all 9 of these points, which is a lot of work, but it's made simpler by the fact that these are all the same triangles, just either above or below the axis. Finally, moving on to part D on this question, part D asks for negative 4 less than x less than 12, 5 all intervals on which g of x is less than 0. So we can actually go back to what we've talked about before. I know that g of x is increasing on this interval because its derivative is positive. I know g of x is negative on this interval. I mean, g prime is negative because f is negative. And so I'm only going to have this spot here where it's less than 0. So because g prime equal to f is greater than 0 on 2, 6, I know that g is greater than 0 on 2, 6. And because the integral from 2 to 6 of f of t dt equals the opposite of the integral from 6 to 10 of f of t dt, I know that g is greater than 0 on 6, 10. I need to put some type of justification here because I need to make sure that I can explain how this area plus this area gives us a 0. And so that means that the integral from 10 to 12, because it's completely below. So because g prime equals f is less than 0 on the interval 10, 12, g is less than 0 on the interval 10, 12. And then I'm going to have to do the same type of argument over here, the fact that these are going to be our negative values, and this is not going to be positive enough to bring it up. So because the integral from 2 to the negative 2 of g of x equals the integral from the opposite of the integral from negative 2 to 2. Why am I saying g? That should be an f. F of x. Then I know that g of x is less than 0 on the domain from negative 2 to 2. And because the integral from negative 2 to 2 of f of x dx is greater than the opposite of the integral from negative 4 to negative 2 of f of x dx, then g of x is less than 0 on the interval from negative 4 to negative 2. So, therefore, g is less than 0 on the interval from negative 4 to 2 and from 10 to 12. Now, there's a lot of stuff to write, but the concept here is a pretty easy concept to understand.